So tell me about yourself. You're the CTO of Citrea. How long have you been working at Citrea?
So, we founded the company behind, like the developer company behind Citrea 3 years ago.
Oh, okay.
It's called Chainway Labs.
Ah, yeah, I remember that. Okay, yeah, okay.
But of course, the main focus and like the branding is all around Citrea, not Chainway Labs. So we founded Chainway Labs 3 years ago between like 4 friends from the same university. We started working on different projects. We were actually like focusing on stuff on Ethereum and other rollups at first.
Okay.
And like with ordinals, we changed our focus, shifted our focus to Bitcoin.
When did ordinals come out? So you said you started 3 years ago.
Yeah, like so we started 3 years ago. And on 2023 February, I guess.
Okay.
Around that time, Ordinals was very new.
Oh, that's right, because it came out like January 2023,
yes,
right?
Something like that. And
that
I think
it
caught our attention like in the first 1 or 2 weeks. We were very interested in the idea that, I mean, I didn't even know Bitcoin can hold so much data in a single block. And that was very interesting for me.
So you were like working on other chains?
Yeah, we were doing different stuff. We were... For a while, we were very famous for proof of innocence. It's a privacy project, if you heard about it.
No, I haven't. Tell me more.
Do you know Tornado Cash?
Yes, I've heard of Tornado Cash.
Okay, so just before 2023 January, if you remember, some US Department of Government banned usage of Tornado Cash and even interacting with the contract.
Yes.
Yeah, and we were like, okay, the reasons behind may be understandable, and we thought that we could use the same technology that enables Tornado Cash, so ZK, for actually making the anonymity set a little bit smaller, and you get to exclude every bad actor from yourself. So you basically prove that, okay, you interacted with Tornado Cash, you pulled some money out, but you weren't one of those depositors that the government says, hey, these guys stole money, like it's like North Korean hackers or whatever, right? So we were a little famous for that for a while.
Cool, okay.
Yeah.
Proof of innocence. It's kind of like marking myself safe from being not a North Korean hacker.
Yeah.
Okay.
And it's actually still being used with a little bit changed, of course, has been applied, but on privacy pools and also Railgun, the proof of innocence technology is still being used.
Very cool.
Anyway, so beginning of 2023, Ordinals came out. We were very interested in Ordinals, and we decided we should do something about it. And that's how we got into Bitcoin. I mean, at least for myself. We built...
we found out you could put data in blocks. That was new. Okay. Okay.
Yeah, we started working on a browser wallet.
Okay.
But while working on the browser wallet, we realized like what you can do on Bitcoin is only like sending money. And we know how strong of a store of value Bitcoin was, and we were like, there's got to be a way you can do DeFi on this, right? Because Bitcoin makes so much sense as a collateral for a stable coin, for example, right? And we were looking for solutions for that. We thought like maybe L2s exist. There was only Lightning as a true L2. There were a few other multi-sig trusted L2s also, like Rootstock, Liquid. Yeah, a few of those also. And we said we started thinking about how we could build something that's actually trustless, or at least trust minimized, brings in never before seen improvements to Bitcoin, as in different transactions, not just like sending Bitcoin over, but actually programming Bitcoin to do different stuff like smart contracts or DeFi applications, you know. So we started researching and like working on Citrea. Back then we didn't even have a name, but I'm gonna say we started working on Citrea.
Okay.
I guess around like summer of 2023. The dates might be a little off because it's been a long time, of course.
It makes sense, yeah.
Yeah. And we set out to make a rollup on Bitcoin. And then the actual bottleneck for security turned out to be the bridge.
Okay, so let me just so you're working on a rollup, is that it, for Bitcoin?
Yeah.
But in order for the rollup to work, it needs a way to anchor itself more or less in the Bitcoin blockchain.
Yeah, so...
And that's the bridge?
Yeah, a rollup, not just anchor itself, by the way. So a rollup can use an L1 like Bitcoin to, have some security from the L1 itself. But that's not so useful, or that's not really something users want when it's only using it for security. You should be able to bridge the L1 asset to L2 and let users use that for transactions and also whatever the users want to interact with. And that requires you to both anchor the state of the rollup into the L1 and also get the state of the L1 verified on Bitcoin, or the L1, if you're speaking in general, so that you can deposit to the rollup and withdraw from the rollup back to Bitcoin, right?
So you want people to basically have like a doorway almost, where they can take their Bitcoin value, get a similar equivalent on the rollup side, participate in DeFi contracts, more programmability on the other side of the L2 rollup that you've built, and then let's say they they participate in a DeFi contract, you make a lot of Bitcoin back or whatever. You need a way to, if you want to, take that back to the L1 and transact there, right? Using L1 technology. And transactions, like normal Bitcoin transactions. And the bridge is what lets you is that doorway between those? Okay, cool.
So, from perspective of the users, this sounds very nice, and I'm sure a lot of people would like to make this work. But there's quite a few security things you have to keep in mind. So, when you're depositing to the chain, are you getting the same amount of Bitcoin? Is there any party that can mint unlimited, Bitcoin on the rollup and make the peg, so make it depeg?
Okay. So basically, they don't put enough Bitcoin on one side of the doorway, but the other side it says they have infinite Bitcoin.
Yeah, that can happen.
Okay.
So
hopefully not.
Those are easy to find out, of course. And,
I see. Okay.
But things like, if I go to a rollup or an L2 solution, what's the guarantee that I can come back to Bitcoin? Is actually, I think, the hardest to answer, and also the most important thing, because not just the process of withdrawing is important, but also if there is any party that can censor your withdrawal, right? So the withdrawal happens on the rollup, and usually rollups have centralized sequencers, so there is only a single entity that can mine blocks, right? Okay. And then they can block you from withdrawing.
That seems like a problem.
That's a big problem.
I mean, you're basically then back to you might as well be on in the US Coinbase or something, right? And that if you're gonna do trading and stuff, might as well be on Coinbase. It's the same trade-off.
Of course.
Right. I see. Okay.
So
how do you avoid that? Is the question, right?
Yeah. So avoiding that, it's not simple, and I think so. When you look at other rollups on other chains, they usually start with baby wheels. They call it, on the bicycles, right?
Okay.
Not all the features of the rollup are there, and you lay the foundation for building those features, and that's what the users are using right now. So on Citrea also, right now, the withdrawals are trust minimized, the deposits are trust minimized. But the censorship side is actually applicable. So since we're running the sequencer, theoretically, we can actually, not include a transaction from somebody to stop them from withdrawing. But
so you could filter transactions, you're saying?
Yeah.
Sorry.
Ironically, of course. But our plan is to have two features that are actually like that are actually built to avoid these problems. One is the forced transactions, and the other one is the decentralized sequencing.
Okay.
Right now, like I think it's like the first priority for the Rollup team after mainnet is working on the forced transactions. A forced transaction is a transaction you make on the L1, but actually affects the state on the L2.
Interesting.
So you initiate some kind of Bitcoin transaction. When you look at that transaction as a Bitcoin node, you don't really know anything about it, but there is some arbitrary data.
Got it. But
the L2 has to use that transaction, and if that transaction is withdrawable, there's no way to censor that, because every node of the rollup, the sequencers of the rollup, if there are many, the provers of the rollup, they all have to look at Bitcoin, and whatever is written on Bitcoin, if it's consensus valid for your rollup, it's gonna have to be included in that chain. And of course, in decentralized sequencing, you have like multiple parties that can, include the transactions in the block, so it's actually easier to comprehend.
So what are the nice things about using Bitcoin as a way to distribute? It's almost a way of distributing the information to all the sequencer provers in the Citrea ecosystem, right? Like on your Rollup protocol, you put data in the Bitcoin blockchain because that means it's like it helps all these different distributed, decentralized pieces of your ecosystem that you've built for your Rollup kind of all have the same source of truth, right? About what the data is. Like all know where to go to look to find that data, right? It's kind of like one reason you would want to use Bitcoin for that data, right? Okay.
So like in the Rollup world, this is usually called the data availability layer.
I see, okay.
Some Rollups have the same data availability layer as their like validator layer, so you can get your Rollup validated, well, I mean like verified or validated, whatever is more correct, I don't know, on one blockchain, and you can post the data on another blockchain. In our case, what we do is we do the same on we do the both on Bitcoin. So why go through the hurdle of doing something like this, right?
Yeah.
There's two things. It's actually about security. So when you have a rollup, at the first steps again, there is some centralization in the way it works. I like to call this like delayed decentralization lately. I don't know if anybody has ever used this term, but for some period of time, you are bound to the L2 level security, but after some amount of time, you're now back to L1 security, and this applies for all rollups actually, right? So because for a time, you have to trust either like your rollup full node or whatever you're getting your information from. But at one point, the L1 validates the state of the rollup. Then that means if there is no bug or anything, as you cannot fool the L1, if it's sufficiently decentralized like Bitcoin, then now it's the security of the L1 that you have to care about. Anyway, so imagine a scenario. There happens some transactions on the L2, very important transactions, let's say billions of dollars of transfers, and people just decide to, after some amount of time, some bug happens on the, L2 code. Okay. So like the node codes, and everybody's storage gets wiped out. I mean, this never happened, but in any blockchain, right? Yeah. But let's say it did. Then what would happen?
What would happen? You have to go back to Bitcoin, right?
So you would. Yeah, I'm coming to that, right? Okay. So you would actually in real life, everybody has backups or whatnot, so you could maybe do something like that. But imagine apocalypse level scenarios, right? Okay. What you can do with Citrea is that you can look at Bitcoin blocks, and then there are some things we call batch proofs. Batch proofs are like ZK proofs for execution of a range of L2 blocks. On those ZK proofs, the outputs contain something we call the state diff. That means when those L2 blocks were executed, the rollup had on its state tree certain changes. Got it. So when you combine those, you can actually build the rollup state to a point, and that point is like the latest the batch proof was sent, right? And
okay, got it. So whatever's happened since the last batch, you don't have record of, but you have almost like checkpoints.
Yeah.
Of what the state on the layer 2 was. So if all the layer 2 data goes away, you have checkpoints that are available on your data availability, which in this case you're putting it in
like
Bitcoin.
This is like the simplest scenario for why DA is important. Another thing would be, let's say your we talked about forced transactions, right? And let's say your forced transactions, in many cases, the way forced transactions work is you have to provide some kind of proof for example, your account on Citrea, so your address had like 10 Bitcoin. So you might have to provide proof that you had 10 Bitcoin on Citrea, right? So that would require you to provide a Merkle proof for the storage tree of the rollup for your address, right?
Oh, that's cool. Okay.
Let's say you're being censored and you cannot withdraw, right?
Yep.
Then how are you going to provide that proof?
You need a bunch of data. You need at least enough data to show where you are from the Merkle root, right?
Yes. So like if a party is censoring you for your transactions, they're not going to also give you the data you need, right?
Right.
So if you haven't set up a full node before, now you have to like find that data somewhere, and let's say everybody is censoring you. Now you can look at Bitcoin and you can extract those data from those ZK proofs. So that's another point. And another reason why you needed to post the data, so you could also do what I'm going to talk about without posting the state diffs, but still you have to post some data at least, is that, you're trying to get Bitcoin to verify your rollup, right? You'll have to at least push some ZK proofs. And the outputs for that ZK proof will include things like the initial state root, the final state root, let's say the height the batch proofs ends at, and stuff like that, right? So even if minimal, you'll have to put some arbitrary data, whatever happens. So yeah, and also you get to use it as a messaging layer, as you also mentioned. So like all the parties of the rollup can coordinate over the.
They all have like a single source of truth, right? That everyone kind of how to get access to. So, okay, so you've got all this data. So you guys, so Citrea recently was basically, there's a flare up in the Bitcoin community about putting data on chain. And Citrea kind of got named as one of the reasons why someone on core decided to make the decision to remove the limits on op returns. Can you explain like what it was that you guys, why were you guys mentioned, like what is it that you're working on or doing for your rollup that made it such that your protocol in particular would not having a data limit on op return is useful? Does that make sense?
Yeah, sure. So it's funny actually. All this controversy stemmed from a single place that we would need like changes for the standard transaction rules, and that's like one of the most minimal ones out there that we could make use of. So I find it very funny. But to explain, so remember we talked about how and why the bridge is so important to the rollup, right?
Yes.
So our bridge is called Clementine, and it uses the very new BitVM technology.
Cool. Very cool.
So since there is no covenants on Bitcoin, in order to make a protocol that forces different parties to act in certain ways or like make certain transactions, you get like let's say 10 people to pre-sign some transactions, right?
Yeah.
And what pre-sign means is like, do I have to explain?
I mean, yeah, go ahead. I mean, it basically means that everyone agrees on what state will end up in certain situations, right?
What chain of transactions can be executed and how, stuff like that. Yeah. So cool.
But everyone always has to like authorize it ahead of time.
Yes. So everybody comes together.
They authorize.
Not physically, but
but they authorize.
They sign certain transactions.
Their signature, and you're authorizing. Okay, if this happens, the money ends up here.
Yeah.
So it's almost like coming together and writing out a very detailed legal contract that everyone signs ahead of time.
Yeah.
and then you ship the contract to chain, more or less. And some of the different clauses of the contract you hold on to as pre-signed transactions, right?
Yeah.
Yeah.
A much better explanation than I could do, actually.
Okay,
Thank you for that. So, so Clementine, the bridge protocol for Citrea, requires a lot of these different transactions to like make the bridge protocol work. And some of these transactions, they have a lot of outputs, for example.
Yes.
And you don't want to have these outputs hold data. So sorry, hold sats, right? Because that would make that would cause the protocol to how can I say this? So if you have outputs that contain sats, you'll have to have inputs that contain sats, and there's a bunch of like 1,000 outputs for a round for an operator, and that means like even with the dust limit, for example, you'll have like inputs that are too big, and that's maybe a burden for the bridge operators, right? So it gets more expensive, basically.
Yes, it gets much more expensive.
So can you make zero value output transactions on Bitcoin right now? It's consensus valid. You can actually do it.
Yes.
But your Bitcoin node, so Bitcoin core software, it's not going to propagate that transaction to other nodes because it's defined as non-standard, meaning that the mempool is not accepting the transactions.
So you can make them, they're consensus valid, but they're not easy to get to a miner to include in a block because they're not considered like relay friendly.
Yes. So like even before BitVM, this was like a issue for ordinals also. Like ordinals, so on ordinals the limit was the problem was the 400 kilobyte per transaction limit.
Yeah.
And people wanted to inscribe, so like put huge images on Bitcoin.
Right.
Right. So that's like
huge is like 4 megabytes.
Yeah. It's huge enough for Bitcoin. So. And people went ahead and like talked to miners, and they had like I guess private deals, and they got to put the 4 megabyte Bitcoin wizard image. That's like the first one. Anyway, so back to command side, there are zero value outputs, for example. So these were actually standardized very recently with the Bitcoin Core V29.
Oh, okay.
Yeah, so that's good for us. But there's still announced a few other I'm not sure actually like one, but maybe more than one. I'm not sure on that because Ekrem, my co-founder, leads the bridge team. Anyways, so there is this challenge transaction. We call it Watchtower challenge transaction.
It's like a lightning penalty transaction, right? Or yeah.
So I guess so. Yeah. So if one of the bridge operators tries to cheat the system, somebody comes along and executes one of those pre-signed paths and says, "Hey, you're making that's
not allowed.
That's not allowed, right?" So
it's exactly like transaction.
So this specific transaction is about what block hash the operator block hash of L1 the bridge operator is committing to.
Okay.
Right. So and then in that transaction we try to put a ZK proof and its output on Bitcoin, so it's like 190 or 200 kilobyte-ish.
Okay.
It's not a huge deal also. We're not kilobytes, sorry, bytes. So like it's around 200 bytes, a very small data actually.
Yes.
This episode is brought to you by BTC++, the premier technical conference series for Bitcoin developers. BTC++ is not your typical Bitcoin conference. It's a world-class gathering of engineers, hackers, and builders focused on the cutting edge of Bitcoin development. From protocol research to Lightning, smart contracts, covenants, privacy tools, and beyond, BTC++ dives deep into the work that's shaping the future of Bitcoin. Join us for our next event in Riga, Latvia on August 7th and 8th, focused on Bitcoin privacy, and see all our upcoming events across the globe at btcplusplus.dev.
So like a normal Bitcoin signature is about 73 to 64 bytes depending.
Yeah.
So this is about 2 signatures or maybe 3 signatures worth of data. Yeah. Okay.
Yeah. So what we do right now is without the standardness changes, you can like put some of the data into an op return, and you can try to put some of the data as like bare multisig outputs, or you can put it into Taproot addresses, right? So there is ways to actually.
You don't want to put it, but one of the things about this that I think is kind of important and interesting is that you don't want to put it in witness data, because witness requires like a commit reveal. You need 2 transactions.
Yeah.
Whereas you guys have 1 transaction and you need all that data to be immediately accessible as soon as you put that single transaction in the chain, right?
I mean, those kind of things are solvable because you can like provide proof that let's say this watchtower challenge transaction commits to some address, and then you can show, hey, this input was spent in this transaction against this block header, and you can show that data is there. That's not big of a deal, but you know, it becomes much more inefficient.
Yeah.
And
it's more data in the chain.
Yeah. You made 2 Taproot transactions now that try to like inscribe data for commit and reveal, and then you have the original transaction with the op return.
So it ends up taking up more block space to do it that way. Yeah. Okay.
And also like, I mean, since I was gonna say like, if you put some data onto a 0 value op return output, then it becomes prunable directly, so nodes don't need to hold on to that data. But on the Taproot side also, since you spend
so much as it doesn't enter the UTXO set.
Yeah.
Right? Yeah.
So it's, yeah. Anyway, so the funny thing to me is like, so this specific transaction with the op return that caused that PR to change the standard rules is, you know, expected to never happen. So if all the actors of the bridge, they act normally, they don't try to cheat the system, this transaction is not going to happen at all.
Right.
So, I mean, if it happens, you know.
But if it does happen, you need to get your transaction mined within a certain time window, right?
Yeah.
It's like, it's a pretty critical, like at least in Lightning, being able to send penalty transactions is very important for the security of your network or your channels, right? I would assume it's the same in the Rollup, right?
Yes.
Like when you need to send those transactions, you like really need to get them in a block.
Yeah. So like that time period can be set by like the developers, of course. So that's fine. But right now, I think there's a few services that help you with mine non-standard transactions, and I think the count is going to increase because nobody wants to leave money on the table. Like I'm talking about miners, right?
Yeah. Right.
So, yeah.
That makes sense.
I don't think it's going to be a huge problem, and I'm not even sure if the Clementine team has implemented the non-standard version for this specific transaction. Yeah, so I haven't really caught up on that, but it's fine. We don't really care if it becomes non-standard or not.
It's not like a blocker for what you're building, really.
It's not really a blocker.
It's like an optimization that would be nice to have. If it doesn't happen, it won't impact what you're doing.
Yeah.
That's cool. Okay.
I mean, if it happens, it's fine. To be honest, though, like I think nobody talks about this, but I'm way more excited about like if Taproot NX bands become standard, because right now, so we put data on Bitcoin in different ways in Clementine, and on Citrea, what we usually do is we do the Taproot commit reveal inscription style.
So hang on, sorry. Just so Clementine is your bridge, and
Citrea is the rollup.
The rollup. Okay.
So on the Citrea side, so on the Rollup software side, we use like Taproot commit reveal transactions to put sequencer commitments and batch proofs. So these are like the sequencer commitment is basically a commitment, like an anchor for the Citrea state on Bitcoin.
Yeah.
And the batch prover proof basically is a ZK proof that proves if you run these sequencer commitments, you get to this state on the rollup, basically, right? So we use the Taproot commit reveals for that, and you know it's 2 transactions per one relevant transaction. What I mean by relevant transaction is like the transactions that the rollup cares about, right? With the Taproot NX, you can have a single transaction that puts that basically has the same properties as these 2. And also the ordinals guys are also very excited about that as far as I'm concerned. And I think they've been talking about this like since the early days of ordinals. I don't know why it never came up to this point, like people describing stuff on actual Bitcoin mainnet. But yeah.
Because just recently someone used the annex to post something.
It's very recent, yeah. And then a few other people, including like one of my co-founders, Orkun, also did it. So it's not actually hard to pull off right now.
But it's not hard. You need to be able to send your transaction directly to a miner, right?
Yes,
is the big thing, because you can't relay annex transactions.
Yeah, so like if annex is standardized, I think that would save us about so we get rid of the commit transaction entirely. It's like
So it doesn't just save you guys though, it saves
everybody.
Everybody, because you guys are only publishing. You want to publish this information. You're currently using 2 transactions to do it. If you can do it in the annex, you can just do it in 1 transaction.
Yeah, and also it becomes much simpler to manage those wallets that you're trying to inscribe data to. So it's not really important, and I don't think not everybody cares about it. But like from a developer perspective, it just becomes easier. It's cleaner.
Yeah, because right now the commit reveal, you kind of have to follow the transaction chain, right, and know what the sync and then what the like reveal is.
So like, since the commit transaction actually commits to the
hash of the script,
so commits to some data.
Yeah.
Right. You first have to like make the reveal transaction, calculate the address that you can.
Yes.
Inscribe from, and then you do the commit transaction. Choosing UTXOs for these 2 transactions is not that straightforward. So like DevX wise, it's also much cleaner to use the annex, but of course it's not standard. So.
I see. That makes sense. Yeah, because it also moves the data away from the big. Okay, I think that makes sense. Yeah, very cool. So we're doing a conference here in Istanbul in a few months. We're going to do the first ever Bitcoin++ that we're focusing on. ZK and scaling is kind of the theme. So we're really hoping. Yeah. So like you guys are using ZK for your rollup stuff. Like you're putting the ZK proofs directly into Bitcoin. I'm hoping that we're going to have some good conversations about what native ZK in Bitcoin will look like. Mm-hmm. If that happens, will that change what Citrea is doing? Will people still need rollups if we can do ZK stuff directly in Bitcoin?
Yeah, so it depends, actually, if a covenant BIP is also accepted. Because with ZK only, you don't get to do much except for like maybe creating, different kind of addresses. But with some covenants, you can actually start like building any kind of program out there in Bitcoin. So you can have like let's say, you can have any kind of vaults. You can even make DeFi applications, so whatever you need. But do you still need rollups? Probably yes. Because if you so programmability is not like the only single thing users need, so we go ahead and build rollups as well. Rollups can help you with cheaper fees. Rollups can help with more transaction volume than the L1 can handle, and that's also very valuable for users, right? So right now, for example, on testnet 4, I don't really remember my latest calculations, but at 1 sat per vbyte, you pay like 150 sats to send some bitcoins with a Taproot transaction for like single input, single output. But on Citrea, you can do that for maybe 10th and
so
send
15
money.
sats.
Yeah.
Instead of 150. Okay.
Yeah, I mean, like, depends on like the chain usage and whatnot, but yeah. So that's the main idea.
So it makes it cheaper to use your Bitcoin.
Yeah, and it'll probably stay that way, as Bitcoin's block space and blocks are much limited than Citrea. But a ZK proposal and a covenant proposal maybe being accepted will help with a lot of things. Right now, the Clementine bridge is trust minimized,
Mm-hmm.
and that means it has one-of-n trust assumptions, right?
Mm-hmm. So you need one person to be honest out of the set.
Yeah. So, and that's also very useful and secure, but having it trustless would be like the ideal way.
Right.
So if you have a ZK opcode, ZK verify opcode, you can actually have Citrea's ZK proofs verified on the rollup directly, and then you can have a trustless bridge, because now Citrea is being verified by L1, and it can, with the covenants also, with additional covenants, you can have the bridge work programmatically. Don't need any operators, don't need watchtowers, don't need signers.
Oh, so it takes away a lot of extra stuff. Okay, so it really simplifies your architecture, it sounds like.
Yeah, I mean, it becomes much more expensive to operate the rollup itself.
Interesting.
But it's something I think everybody is willing to pay for, to have trustless bridges, right?
I see. Okay. I mean, it's kind of that's a good question, right? Are people willing to pay for that kind of security? But yeah. Okay.
Yeah, I mean,
I see.
If that happens, we'll see, I guess.
We'll see.
Yeah.
To be determined. But we need some things to happen at the layer 1 first. Yeah. So hopefully these are hopefully things we'll be talking about at the conference in Istanbul. At least that's my hope. We can talk about what zero knowledge proofs and scaling look like for Bitcoin and scaling, and how BitVM is kind of, I think, ushering in some of these new rollup technologies ahead of having make any changes to layer 1. So that's really cool. So how can people find out more about Citrea? Are you on social media? Or?
Of course, yeah. Our Twitter page is Citrea XYZ. You can go on Citrea.xyz for the website, and also to bridge testnet for Bitcoin to Citrea and start using, of course, the testnet.
Cool.
There's also a bunch of cool explorers there. Maybe you want to check it out. Yeah.
Cool. And what about yourself? Are you on social media?
Yeah, I'm also on Twitter, or X now.
Yeah.
Under Esad, Yusuf, Atik. I think if you search for Esad stream, I might come up.
Cool. We'll post it in the notes too, or tag you so people can find you.
Right.
Great. Well, thanks for your time, Esad.